Jim Sinesco, and I'm the Vice President of AFC International, Gas Detection, Air Monitoring, and Respiratory Specialists. Today we're going to talk a little bit about, in this snippet at least, a little bit about detector tubes. I think just from going around doing this for 20-some years, I found out that a lot of people, whether good or bad, find tubes not to be, detector tubes, not to be the state-of-the-art technology that they want to use in their gas detection program. Hopefully, I can go over some of those issues with you in this little 5-10 minute snippet here and kind of show you how valuable tubes can really be. Even though they've been around a long time, the technology's been around, geez, probably from the early 1900s, detector tubes still have a very, very major role and a place in our gas detection air monitoring programs. Whether it's for hazmat, first response, industrial hygiene, safety, and health, detector tubes have some major advantages over some of the newer technology that's out there. But basically, let me talk a little bit about what detector tubes do and what they are. Basically, gas detection tubes, and this one happens to be a Draeger detector tube, are a sealed ampule or sealed tube with chemical or reagents for whatever particular gas you're looking for that will react to that gas and vapor. This one's an ammonia gas sample tube. So this reagent or chemistry has been designed to stain or change color in the presence of ammonia. It also is designed to quantify. I'm going to go ahead and zero in on this tube here. Actually give you an exact reading, relative, plus or minus, of how much ammonia you have. And you can see here very clearly, you can see the indication here at 5 ppm all the way upwards. I believe that is 70 ppm. So detector tubes can be used for quantitative levels of gas and vapor that you're encountering. Now, the reagents inside this particular tube are designed to try to pick up ammonia or very like chemical family gases and vapors, okay, amines in this case. They try to do their best when they produce these tubes to not have cross-interfering gases and vapors, or to at least minimize the number of cross-interferent gases and vapors that you might have in the field. Why would that be a problem? If I design a detector tube for ammonia, but yet it produces or detects carbon dioxide, that would be a problem. Why? Because we have carbon dioxide in the air. We exhale carbon dioxide. So an ammonia tube that has a crossover to carbon dioxide, not a good fit. Now, I'm not just kidding around here. They don't make a tube that does that. But you may have other gases and vapors in the area that may give you a false positive. All right? So the real craft, the real technology in detector tubes is to try to get them as gas specific as possible, or at least limit the number of interferences from other gases, common gases and vapors. So this really is the main reason, or a really major reason, that help tubes still be part of your future and potential current gas detection programs, because they can actually give you a specific gas or vapor or chemical family. Many other technologies out there in automated gas detection instruments suffer from cross-contamination or cross-sensitivity to other gases and vapors. A real common detector that's used nowadays is a photoionization detector, or PID. Another one is a flame ionization detector, or an FID. These detectors are very excellent. They're very good, very quantitative, but they are general detectors. That means that they will see many different gases and vapors, and it will not tell you what you have. Another one is the combustible gas sensor. On most confined space gas detection instruments, you have a combustible sensor. That is a general detector. It will burn anything that wants to get burned. You pull it in by a sample, or you just use it in diffusion mode, it's going to detect something there. It's not going to tell you what it is. So the problem with FIDs, PIDs, general gas sensor detectors like catalytic bead sensors, LEL sensors, is that they suffer because they can't tell you exactly what you have. They can give you an idea, and then you have to kind of figure out from where you are, what you got around, placarding, what you have. Detector tubes actually help us with these other detection methods. On their own, they're great, but in conjunction with these other detectors, they can really help you out when you're trying to figure out what you actually have. Okay? So anyway, this reagent is made special, or tried to be limit the number of cross sensitivities. Okay? We then would break the ends of the tube. We would then insert it into a pump. This happens to be a Draeger billows pump. You want to definitely use the same manufacturer of tube that you are using with the pump. You break both ends of the tube. Most of the tubes have an arrow pointing inward towards the direction of flow. You'll compress the billows and release, and the billows pulls in an exact amount, 100 milliliter sample of air from that environment through the tube. Now, what I'm going to show you, before I break these tubes, this tube here, I want to show you something you should always do prior to using a detector tube in a pump. Whether it's a piston pump from other manufacturers or a Draeger billows pump, what you want to do is you take an unbroken tube, in other words, a tube that has not been broken on both ends, insert it into the pump, and completely compress the billows. And what happens? Since the air can't go anywhere, we're actually doing a seal check on this thing. You can see that I can just leave this on my desk here, and it will hold this vacuum, hold this seal for at least a minimum of a minute. That's the easy test, the quick test. The long-term test would be a 15-minute time period to really make sure that the rubber components, the diaphragms, and all the seals are actually holding. And you can see this billows is not going anywhere. Okay, so I'm going to go ahead and pull that tube out and let the billows come back to normal. I also want to show you on the Draeger Akiro pump is this little white little indicator. When I compress and release, that billows opens up and closes and opens again. When I put a tube that's not broken, I want to take a look at that indicator. What's going to happen when I compress? That little white eye, it's hard to see on the video, turns to a dark black look. Once the pressures and the sample is completely gone through the pump, the white eye comes up telling me that the full 100 milliliter sample has been drawn through the tube. So it's called an end of pump or end of stroke indicator. Okay, so that's important to make sure that that's functioning as well. You'll also find on the face of an Akiro pump is a counter. I'm going to go ahead and it's the number of pump strokes we've actually taken. I'm going to zero in on this. There you go. So right now it's saying 12. To reset that counter, all we do is you take an unbroken tube, and I'm going to have to turn it around. You're just going to depress this little button here, and we reset it to 0. Again, that's right here. You can take a pencil or a pen, but an unbroken tube is an easy way to do it. It resets it. Okay? So, what I'm going to do next is I'm going to go ahead and I'm going to open this up, this tube, open it up. I'm going to go ahead and show you how we actually insert the pump and tube together here. So, wide out a little bit here for you. I'm going to also take the tube opener. It comes with every Akiro pump that you purchase from Draeger, from us. It's got 2 holes, a center hole and an outermost hole. Okay, the center hole, there's a little score way down deep inside. These are glass tubes, so we want to make sure we don't just have glass all over the place. We take the tube, we cant it just slightly with our finger, and we rotate that tube. Now you can't probably hear it on the video, but it sounds like screeching glass, like we're cutting the glass. We're scoring it, and that's perfect. Once we go around a few times, we take the tube out of the middle hole, we go to the outermost, and we punch down. And you hear it snap. It cut that tube perfectly off, nice and square. We do the other side. Careful not to cut our finger. We want to be careful here. You hear the scoring. I'm turning it. Put it in the number 2 hole. It punches it off nice as well. Okay. At this point, we've already reset our pump. We're going to look on that tube and look for an arrow which shows indication of which way the flow is going. Again, this is an older tube, so it's not as clearly defined as the new ones now, but we want to definitely make sure it goes into the pump with the arrow pointing in. Also on the tube, it'll say an N equals number. N equals the number of pump strokes we're going to actually complete to make this tube and the scale on this tube valid. All right. So before I do anything, before I even take a pump, I'm going to go ahead and bring in some ammonia. Now it's very tricky when we're trying to, give you a an environment of a target gas. Obviously, when I open up this jar of ammonia, or this big jug of ammonia, we've got a high concentration. This tube would almost stain immediately. So what I'm going to try to do is just use the cap, and I'm going to go ahead and take the pump, completely compress it. If you need two hands, that's fine, but most people should have no problem with one hand. Compress it, and I'm going to try to get it as close as I can to that cap. And you can see the billows is starting to open up. The eye is black, and now you can see the eye has turned white. So that's my first complete pump stroke. Okay, I'm going to get a little closer now and do a second pump. See, the eye is black. Okay, pump stroke is complete now because it's a white eye on the indicator. I'm going to go ahead and get even closer to try to mimic. And you can see, let me zero in on this. That's our third pump stroke. You can see already I'm getting a stain on that detector tube. I'm going to pull it back right about there so you can see. That's 3. Compress again. And you can see that stain is starting to form. Indicator's white. Squeeze again. All right. I'm going to go ahead and cap this up. I'd still have to do 5 more pump strokes. I'll go ahead and do one more in clean air here, but obviously I wouldn't be sticking it in the neck of a jar full of ammonia. Or maybe you would. Maybe you're trying to figure out what's inside this jar. And that's the beauty of the detector tube. Maybe you don't care about the scale. You just want to see if that ammonia reagent that's inside there is actually reacting with something that's an amine, or basically an ammonia-based compound. And you can see here very clearly that we're getting very good color. I'm going to walk up here and show you. Very good stain. And I'm going to read it off for you. It's right around the 40 mark. So in other words, 40 part per million is right about there. Okay? So that brings us to, how do you read a detector tube? Well, basically for detector tubes, we just take a look at the length stain, the farthest length of stain, regardless of color or shade, and take that reading. Now, some industrial hygienists and safety people will do a couple things. They'll take the farthest super stained, really very, very good separation stain, and even if it diffuses slightly a bit, they'll take that mark as well, take those readings and average them. A lot of people do different things, but from my training from Draeger, you take the farthest length of stain, regardless of color or shade, and that is your reading. Now, obviously, you would have to finish the rest of our pump strokes before we did that. Obviously, I don't have a good source for sticking it right inside the jar of ammonia, so we're not getting a real good representative of an environment of ammonia. But at least you get the idea of how we can see that stain and that activity. So after 10 strokes, we go ahead and pull that tube. We take an immediate reading. We don't want to wait. The stain will diffuse a little bit longer and more as you let time go, so you definitely want to immediately look at the reading, and there you go. There's your reading of the ammonia of that time. So, what have we done? We've taken a snapshot of this environment right now, right here, with a detector tube, and we've confirmed that we have ammonia or an amine of some sort. One of the tools that can help you is the Draeger. I call it the Draeger Detector Tube Bible, okay? It's a Draeger Tube and CMS Handbook. Now this one happens to be the 15th edition. If you give us a call here at AFC at 800-952-3293, if we have supplies around, we can certainly get you out this and put you on the list for the next version. But definitely give us a call. We'll see what we can do to get you one of these in your hands. There is no cost that I know of on these, but we can do check with Draeger on that. But it's a very, very good reference book. What you have inside here is each individual detector tube, what it looks like before the test and after the test. And I'm just going to go ahead and read the ammonia tube that we were using and give you some information. on this tube. Okay. And it's right here. It's an ammonia 5A tube. And I'll read because you can't see it very well, but it says standard range 5 to 70 part per million, 10 pump strokes. Okay, N equals 10. Time for measurement, approximately 1 minute. So they're saying to do 10 pump strokes, it's only take 1 minute. Not a bad deal. Standard deviation, basically when you read your reading, plus or minus 1. This one says 10 to 15% of reading. That's pretty good. It gives me at least an idea of how precise and accurate am I. It gives me a color change, yellow, orange to blue. And actually the picture here, now that they're in color, shows that actually going on, and we match up our stain and go, yep, that is ammonia. That's definitely the color we want. Temperature range, it gives you the temperature and pressure that we can, and humidity that this tube can be administered into. It actually gives me the chemical reaction. If you're a chemist, you really want to find out what the heck's inside there and what's going on, you can see. And then the main important one that I think is really the most important in use of this detector book and using of detector tubes is cross sensitivities. Other basic substances such as organic amines are indicated as well. And he has some indication. Indication is not affected by 300 part per million of nitrous fumes, 2,000 part per million sulfur dioxide, and no influence from 2,000 ppm hydrogen sulfide, which could be very common interferent gases for ammonia. So right there I can see, wow, okay, it's going to see other organic amines. Doesn't say anything else, you know, a few other little things, but it doesn't say any influences from other things else. So when I'm using a general PID detector, which can see ammonia, but it can see other things too, I can really make sure a PID is reading ammonia by using a detector tube, because the tube will turn colors in the presence of amines. If it doesn't, and my PID is reading something and my tube shows nothing, I can say that it's not an amine. I can say it's not ammonia. At least fairly confident I can say that. So using detector tubes or colorimetric detection, direct reading instrumentation tubes come in very, very handy when you are trying to determine what your other detectors are showing you that are more general and broadband. Okay. What I'm going to do, I'm going to go ahead and zoom out a little bit, and I'm going to show you another type of detector tube that is probably not as well known, but I think is also very, very useful for industrial hygiene applications, or a mock area monitor where we can actually see concentration over time, is Draeger's diffusion tubes. Now, Draeger diffusion tubes, we don't use the Accuro pump. The Draeger diffusion tube is a tube that we will break both ends of the tube. Looks just like a regular detector tube. But instead of doing a direct read right now, instantaneous, couple minute test, it's designed to run between 2, 3, 4, up to 8 hours of runtime. Okay, and you can see, I'm going to try to get this zeroed in for you. It doesn't like it. It doesn't like my shirt there. There you go. You can see the scaling on it. The scaling is in ppm hours. So what's going to happen here? We're going to go ahead and break the tube. Now the tube is used not with the pump, but with this tube holder. Now the tube holder actually does two things. It's a tube breaker. And you'll see on the tube there's a red indication mark where it needs to be broken. This one happens to be, by the way, a carbon dioxide tube. So we're going to slide the tube into the holder and slide it all the way up. And you'll see the little red indication mark right there. And the tube holder actually flexes. So when we get it in that position, we're going to go ahead and snap. Look at that. We just broke the tube in half. We pull the bigger section out. Put that on the table for now. We want to dig out that other portion, which is basically an empty tube end. We're going to take the tube, reverse it, the big side, reverse it, and put it back up in its holder. I sometimes use the table to push it all the way up. Now if you do this right, you want to have that scale so that it shows, excuse me, it shows right on there the actual scaling, and it's got a clip. We would then clip this on our lapel of our worker, or clip it in an area. Go ahead and zoom out. So now, when we go to do our work, I've got the Draeger diffusion tube on me, and as the gases and vapors I encounter in the area that I'm working, they will then use fixed law of diffusion and diffuse up into this detector tube from the bottom up. Start to discoloring and give me readings on that range. Once you get you're done with your work for the day, let's say 8 hours later, you take your tube, you look at the farthest length of stain, and then divide that number, whatever it says on the thing, divide it by the number of hours you've actually deployed or had that on you. That will give you a very basic, simple time-weighted average, and it basically is what we use to make sure that we're either exposed or not exposed in a given day. So Draeger diffusion tubes should be used a lot. It's a very, very useful detection means. The short-term detector tubes also with the billows can be used very well too, very effectively. Same rules apply as far as cross interferences and cross contaminants, false positives. Those also can be found in the tube Bible or the tube book. The diffusion tubes are in there as well. So that's what I wanted to show you today, was a little bit about detector tubes, short-term tubes, diffusion tubes. Draeger tubes can be used for lots of different uses. So please give us a call if you have any questions. You want to see more about this, find out more information, give us a call, 800-952-3293, or look on our website, www.afcintl.com. You'll find spec sheets, cut sheets, all the ordering information you need will be on our website. Give us a call at our 800 number and we can help you out with whatever you need. Again, thank you very much for watching.